Hey guys, I'm going to show you how to use two-way tables to describe the sample space of two concurrent events. So let's just look at this straight away with an example. So the example here we got, two letters are chosen from the word kick without replacement. We need to construct a table to list the sample space, and we need to find the probability of obtaining, certain outcomes. In the event that we pick a letter from K and then we pick a second letter from K without replacement. So let's get started by drawing up our table. There's going to be along our borders, we're going to have event 1 and event 2. In event 1, my possible outcomes, I'd be able to pick a K, an I, a C, or a K, another K. Event 2, I'll also be able to pick a K, an I, a C, or a K. Alright, so what we're saying when we say without replacement, that's just saying my first event, my options are K, I, C, K. Let's say I pick an I, alright? So what that means, I pick this I and I remove it from my set. So now in my second event, I'm only able to select from K, say C or K. I've removed I from my set and I have not replaced it. In the event that I select two letters from the word kick with replacement, that means I select I in my first act, and then in my second act, I replace I back into my set, and it is able to be selected again in my second act or my second event. Alright, so here we're looking at the case without replacement, so that means in my second event, I won't be able to select I if I select it in my first event. Alright, so with that in mind, we'll draw out the rest of this table. Alright, so if I pick this first K in the first event, and I don't replace it back, that means I'm not going to be able to select it in my second event, so this is impossible. If I select an I in my first event, I'm perfectly able to select a K in my second event, right? So we're just listing possible outcomes right now. I'll go through and list these as quick as I can. Here we are able to select two Ks because these two Ks are different. This is the K at the end of the word kick, and this K is the K at the start of the word kick. So they're different Ks, so we're allowed to have this outcome here. But anyways, moving on. Ki. That would be impossible because we are not replacing. Ci, Ki, Kc, Ic, Cc would be impossible, and Kc. I'm listing horizontal first, as in X then Y. And we'll have Kk. This would be possible because again these are the different Ks, one at the start, one at the end. Ik, Ck, impossible. So here's our sample space. We haven't put it into a nice little set like we might like to, but that's fine. We've listed out our sample space. We can see all the possible outcomes here. This is the set of all possible outcomes, hence it's our sample space. So A, done. B, let's find the probability of certain events. So the first one, obtaining the outcome Kc. So if we look here, well, first of all, we're talking about how many events. Our sample space includes how many outcomes. Well, there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes here. So out of 12, how many of these outcomes are the outcome Kc? And Kc, by the way, is not the same as Ck, right? This is saying that our first event, we pick a K, our second event, we pick a C. Here we're saying our first event, we pick a C, our second event, we pick a K. So they're different outcomes. So Kc, well, let's go through and find out how many we got. So 1 over here, it's 2 over here. And that looks like it. So there are 2 out of 12. 1 in 6 outcomes. Probability of selecting 2Ks. Again, out of 12. Let's look for the outcomes with 2Ks. There's 1. There's 2. There's no more. So again, 2 out of 12. 1 in 6. Probability of selecting a K and a C. So here we're not caring about the order. We just want to know, do we have a K and do we have a C? So out of 12 outcomes, we got K and a C there, K and a C there, K and a C there, K and a C there. We got 4 out of 12 outcomes with a K and a C. 1 and 3. Last one. Selecting 2Ks given that at least 1K is selected. So if this were given here, if I were to write this out sort of mathematically, I would say the probability of selecting a K given 1K is selected, or however I would write these two things. This little symbol here, this means given. So the probability of some event given some other event. Okay, so all this means, it means that when we talk about the probability, it's no longer going to be out of all 12 outcomes in the sample space. It's going to be out of the events that we select at least 1K. So what's the probability of selecting 2Ks given that at least 1K is selected? So out of all the events where at least 1K is selected, how many events do we have where 2Ks are selected? So let's go through and count all the events with at least 1K. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 events with at least 1K. So we're not looking out of the full sample space. It's given the outcomes have at least 1K. That's only 10 of the 12 outcomes. So out of the 10 outcomes with at least 1K, how many outcomes do we have 2Ks? Well, there's 1, 2. So 2 outcomes have 2Ks out of the 10 outcomes that have at least 1K. So we can simplify that to 1 and 5. Here is final answer. I'll zoom out so you can kind of pause and have a look for a second. But that is all.